Hello students, welcome to Cbse Maths class. Today in the new video, I'm going to discuss new chapter and a new concept. The new chapter is arithmetic progressions. So before going to arithmetic progression, we must know what is a progression first. Progression, a list of numbers arranged with a certain rule is called as progression. Here is a rule. According to the rule, there are three types of progression, that is arithmetic progression, geometric progression, and harmonic progression. For class 10th, you have only arithmetic progression. This geometric progression and harmonic progression you will be learning in class 11th. So let us see first what type of list of numbers forms an arithmetic progression. Two examples I have taken here: 5, 9, 13, 17, dash, 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 15, 12, 9, dash, dash, dash. You can observe the numbers. There is some relationship exists among the terms of the progression. Which are the terms here? 5, 9, 13, 17, they are the terms of the progression. What relationship you are observing between the terms of the progression here? That is, don't you observe this? 9 minus 5 is 4, 13 minus 9 is 4, 17 minus 13 is 4. Okay, that means the consecutive terms of the progression differs with a constant number in this list of numbers. What is that constant number? It's differing plus 4. So 5 plus 4, 9. 9 plus 4, 13. 13 plus 4, 17. So that means the common difference is existing among the terms of the progression. Then that progression we will call it as arithmetic progression. The rule is by adding the common number, you are getting the subsequent terms of the progression. Then such progression is called as arithmetic progression. So to check, usually the first term always will represent it by A. A is equal to 5. And A, B, and C, three continuous terms or consecutive terms will be taking for checking the common difference. So common difference D is given by B minus A is equal to C minus B. What is B here? 9 minus 5 is equal to 13 minus 9. What is 9 minus 5? 4. 13 minus 9 is also 4. So common difference is equal to 4. When the common difference exists among the terms of the progression, then that progression will become arithmetic progression. Okay, here one example I have taken where the terms of the progression are in ascending order. Here, the second example I have taken is 15, 12, 9. So don't you see these terms are in the descending order? And here also let me take A, B, and C. Here also you can observe some pattern, this pattern of numbers, how they are advancing. So first A is 15 and B is 12 and C is equal to 9. Let us check the common difference. D is equal to what? B minus A is equal to C minus B. B is what? 12 minus 15 is equal to 9 minus 12. What is 12 minus 15 minus 3? Is equal to 12 minus 9 minus 12 minus 3. So D is equal to minus 3. Shall we check what is 15 minus 3? It is 12. 12 minus 3 is equal to what? 9. Okay, 9 minus 3 gives you 6. That means like that the list of numbers will reduce from 15, 12, 9 and 6. It goes on like that. So that means what is the common difference here? Minus 3. So when the common difference exists among the terms of the progression, that progression we will call it as arithmetic progression. So like that. So to call the given progression as arithmetic progression, there should be always common difference exists among the terms of the progression. Okay. Now let us check if a question based on this arithmetic progression. If 2k plus 1, 3k plus 3, and 5k minus 1 are in AP. Already they are saying that these terms are in AP. Find K. What is the value of K for which the given terms are in arithmetic progression? Let me take this as A, B, and C. Since it is mentioned that the terms are in arithmetic progression, shall I write D is equal to B minus A is equal to C minus B? B is what? 3K plus 3 minus of 2K plus 1 is equal to 5K minus 1 minus of 3K plus 3. 3K plus 3. So that gives you 3K plus 3 minus 2K minus 1 is equal to 5K minus 1 minus 3K and minus 3. When you multiply, when you open up the brackets. So shall we simplify here? 3K minus 2K is nothing but K. Plus 3 minus 1 is plus 2 is equal to 5K minus 3K is 2K. And minus 1 minus 3 gives you minus 4. Okay. So the next step will be 2 and minus 4 will become plus 4 is equal to 2K plus K will become minus K. 6 is equal to K or K is equal to 6. So when the terms are in arithmetic progression, to get the unknown value here K, we have made use of this common difference property. Common D is equal to what? B minus A is equal to C minus B. Next, by making use of the terms of arithmetic progression, let us derive one formula. That is, we need to find the nth term of the arithmetic progression. Tn or nth term of AP. Nth term of AP. So before deriving that, one example I will take for arithmetic progression, and by making use of only the first term and the common difference, we will write that series. So let me take an example. 7, 10, 13 are in AP. Are in AP. Here, what is A here? A is equal to 7. And what is common difference? D. 10 minus 7, 3. 13 minus 10, 3. D is equal to 3. Now let me write this 7 plus 3, 10. 10 plus 3, 13. 13 plus 3, it gives you 16. Okay, one more term I am taking. By making use of only A and D, I will write the arithmetic progression which is given to us. So what shall I do here first? 7 I will write as it is. Okay. 7 I will write 7 plus 0 into 3. I am using A and D only. 0 into 3 is 0. 0 plus 7 is 7. That is the first term. Come in. 7 plus 1 into 3. What did I write? A plus 1 into D. So that is 1 into 3, 3, 7 plus 3, 10. The second term we got. Okay. And the third one, 7 plus 2 into 3. Okay. I am using only A and D and writing the given arithmetic progression. What is 2, 3 is a 6. 6 plus 7, 13. 13 is satisfying or not? Next term, if you want, 7 plus 3 into 3. That is 7, 3, 3, 3 is a 9. 9 plus 7, 16. So all the terms of the AP, we got it by making use of only A and D. This example will help you to derive your general formula. Okay. So what is the general formula? Nth term of AP will derive now. So if you want to write the general term, what I will write here? A plus 0 into D. Okay. The next second term, if you want, A plus 1 into D. Third term, A plus 3 in A plus 2 into D. A plus 2 into D. Next term, if you want, A plus 3 into D. Like that, it continues. Now observe, this is your first term. What is your first term? Is A plus 0 into D. And the second term is A plus 1 into D. And the third term is A plus 2 into D. And the fourth term is A plus 3 into D. Observe carefully here the particular term and the coefficient of D. Term is 1, coefficient of D is 0. Term is 2, coefficient of D is 1. Term is 3, coefficient of D is 2. Term is 4, and coefficient of D is 1. D is 3. What you are observing here, the coefficient of D is 1 less than the particular term. Okay. So 1 and term is 2. Coefficient of D is 2, term is 3. And coefficient of D is 3, term is 4. Suppose if the terms continues like that up to n terms. Okay, shall we write the general term here? That is A plus, what should be the coefficient of D? 1 less than n. That is n minus 1 into D. Okay, so therefore Tn is equal to A plus n minus 1 into D. Okay, so this is the formula to find a particular term of the arithmetic progression. That is Tn equals A plus n minus 1 into D. Sometimes we'll denote this also as a last term. Okay. How this formula is useful to find a particular term of the given arithmetic progression. Suppose for example, this we will take the same example what we have taken now. 7, 10, 13, 16. Suppose we want the 1, 2, 3, 4. Fifth term we want. We will check what will be the fifth term here. So that is Tn is equal to A plus n minus 1 into D. Okay, sir. So what is your A there? A is equal to 7. N means we want, which term we want? Fifth term. T5. That is 5 minus 1. What is the common difference? Already we have checked. It is 3. When you simplify this, 7 plus 5 minus 1 is 4. 4 into 3. That gives you 7 plus 12. What is 7 plus 12? That is 19. Okay, that means fifth term of that progression should be 19. Shall we check their fifth term? 7 plus 3, 10. Okay, sir. 10 plus 3, 13. 13 plus 3, 16. 16 plus 3, 19. Is it not the fifth term we check? 1, 2, 3, 4, 5. The fifth term we got 19. Purposely I took small number so that you can check with the progression you have written. Okay. For example, you want for the same example, you want the 26th term you want. Okay. You want 26th term for the same progression, or a progression also you can change it. Why to use the same progression? Okay. Let me take example 1 here, or example 2 already I have taken now. Find the 25th term of 2, 5, 8, dash, dash, dash. And here what is A here? A is equal to 3. And common difference D is equal to what? 5 minus 3. 5 minus 2, 3. 8 minus 5, 3. So D is equal to 3. And we want 26th term. N is equal to what? 26. So that means Tn is equal to what? A plus n minus 1 into common difference. So that is A is equal to what? A is not 3. A is equal to 2. So that is 2 plus n minus 1. And we want n T26. T26 is equal to 26 minus 1 into common difference is equal to what? 3. So which is equal to 2 plus 25 into 3. That gives you what? 2 plus 25, 3 is 75. 75 plus 2 is 77. That means the 26th term of that progression will be 77. So this is how this formula will be used to find out the particular term of the arithmetic progression. Okay. Now, the next type of question is what? You will be given the last term and the progression terms will be given to you. You need to find out how many terms are there from first term to last term. Okay. Which term of an AP? Which term of an AP 3, 8, 13, 3, 8, 13, dash, dash, dash is 78. Okay. In between, the terms are missing. Okay, you need not write all the terms, say from 3, 8, 30, 3 plus, what is the common difference here? 5. 3 plus 5, 8, 8 plus 5, 13, 13 plus 5, 18. It's like that, you need not write up to 78 and count and say, this many terms are there from 3 to 78. So we will make use of the nth term of an AP here. Before that, we will list out what is A, D, and L. A is equal to what, sir? 3. What is the common difference? 8 minus 5, 3, 5, 13 minus 8, 5. D is equal to 5. And what is the last term? Last term is equal to 78. So, Tn is equal to A plus n minus 1 into common difference is equal to L, where L represents the last term. So, we know all the values except n. A you know, D you know, L you know, only n is unknown. That unknown value we will find out now. What is A? A is 3 plus n minus 1 into common difference is equal to what? 5. Last term is equal to 78. What I will do, this plus 3, I will transpose to RHS. So this will become n minus 1 into 5 is equal to 78 minus 3. So that is n minus 1 into 5 is equal to what? 75. You need to find the value of n. That means divide both sides by 5. That we will eliminate that 5 also. This 5 and 5 will cancel. What we got? N minus 1 equals 5 divides 25 how many times? 75 how many times? 5 ones are 5, 15, 5 are 75 no? So n minus 1 is equal to 15. So n is equal to 15 plus 1 is equal to 16. What does this n equals 16 indicates? N equals 16 represents there are 16 terms from 3, 8, 13, dash, dash, dash. So that the 16th term will form 78. So you need not write all that 16 terms to come at the conclusion that there are 16 terms from 3 to 78. Okay, I hope all of you understood this. Okay. The next, fourth question. How many 2 digits numbers are divisible by 3? Question is, how many 2-digit numbers are divisible by 3? Divisible by 3. So your question, which is the first 2-digit number? Let us write first. First 2-digit number is 10. What is the last 2-digit number? 99. Okay. So how many 2 digits number are divisible by 3? Will you say that 10 is divisible by 3? Okay. Okay, 10 is not divisible by 3. After 10, which is the first number divisible by 3? 11 will not be divisible. 12 will be the first 2-digit number. Next 2-digit number divisible by 3 is 15. After 15, what is the next number? 18. Right? The multiples of 3. Okay. If you continue like that, 99, is it not divisible by 3? So this 99 is also divisible by 3. So the 2-digit numbers which are divisible by 3 are 12, 15, 18, 999. So that totally 99. Last digit is 2-digit number divisible by 3 is 99. How many 2-digit numbers are there from 12 to 99? Means again you need to find out n. So A is equal to 12. Common difference D is equal to, it is multiple of 3 means D is 3 only, no? And L is equal to what? 99. So we will use the formula Tn is equal to A plus n minus 1 into D is equal to L. So what is your A you substitute there? It is 12 plus n minus 1. We don't know that is how many terms are there into common difference is 3 is equal to 99. So n minus 1 into 3 is equal to 99 minus 12. Okay, sir. So n minus 1 into 3 is equal to 9 minus 2, 7. 9 minus 1, 8. So divide both sides by 3. Okay, sir. That 3 and 3 cancels here. N minus 1 is equal to 3 cancel 87 times. 3 2s are 3 9s. So 29 times it cancels. Therefore, next n is equal to what? 29 plus 1. So n is equal to 30. That means 30 two-digit numbers from 10 to 99, that is 12 to 99, which are divisible by 3. So there are 30 what you call two-digit numbers which are divisible by 3. So here also we made use of nth term of an AP. Next question, find the 20th term. Next question, find the 20th term from the last term of AP, from the last term of AP, the AP which is given to you now. AP, what is that? 3, 8, 23, 3, 8, 13. It is first term 3, no? 3, 8, 13, dash, 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 253. 253. You are asked to find out the 20th term from back, which is the 20th term, not from starting 3, 8, 13 and the 20th term. From back, we want the 20th term. So what you do here, we will write the terms in the descending order now. The terms which are given to you is in ascending order. Let us write it in descending order. So the first term will become what? 253. What is the common difference here? 8 minus 3, 5. 13 minus 5, 8. That means keep subtracting 5, 5 from 253. 253 minus 5, 248. 248 minus 3, minus 5 is 243. Correct, sir? Dash, dash, dash. When you come back, the first term will become A, that is equal to, that A will become the last term here. Okay, sir. Now we want the 20th term. So that means A is equal to 253 and D is equal to, now the terms are in descending order now. The common difference will be minus 5, no? 248 minus 253 minus 5. 243 minus 248 minus 5. Okay, sir. We want n is 20th term. N is equal to 20. So Tn is equal to A plus n minus 1 into common difference. So what is your A here? 253 plus n is what? 20 minus 1 into common difference is equal to what? Minus 5. Are we correct, sir? So which is equal to 253 plus 20 minus 1, 19. 19 into minus 5, which is equal to 243. 19 5s are 95 minus 95. So 243 minus 95 gives you a 13 minus 5, 8. Okay, sir. Then 13 minus 9. Okay, 13 minus 5, 8, no? Again, 253, sorry, not 243. This is 253. It is 253 minus 95. That is 13 minus 5, 8. 14 minus 9, 5 and 1. That gives you 158. So that means which is the T20. So T20, that means 20th term from back or from the last term is 158. Okay. Shall we do one more, the last problem and the fifth question? This very important question. Which term of AP? Which term of AP? 3, 15, 27, 3, 15, 27, dash, dash, will be 132 more than 132 more than It's the 54th term. It's the 54th term. So here also let me list out what is given to us. A is equal to 3. Common difference D is equal to 15 minus 3 is 12. And 27 minus 15 also 12. Okay. This 132 is not the last term here. So we have to find out a term that is Tn, which is equal to 132 more than its 54th term. It is a T54. Okay, sir. So Tn is equal to T54 plus 132. Okay. Which term will form that? Okay. There will be a particular term which is 132 more than the 54th term. What is that particular term? We have to find out now. So Tn is equal to formula. What is that? A plus n minus 1 into D shall be used. So A plus n minus 1 into D. T54. Here also we will use A plus n minus 1 into D plus 132. We'll substitute what that here n is 54. So A is equal to what? 3 plus n we don't know. That only you have to find out which term. Common difference is equal to what? 12 is equal to A. Again for the same series it is A is equal to 3. And here n we know. 54th term is n is equal to 54 minus 1. And common difference is equal to what? 12 plus 132. Okay, sir? So now shall we do one thing? If we transpose 3 to LHS, that become minus and plus 3 and minus 3 will cancel. So what is left over now? N minus 1 into 12 is equal to 54 minus 1 is what? 53 into 12 plus 132. 132 shall I write it as 12 into 11 or 11 into 12? We can write it as 12 11s are 132 only, no? That is 11 into 12. Okay. If you want, you can multiply it here. 12 into 11. 11 2s are 22. 2 carry 11 ones are 11 plus 2 13. So 132 can be written as 11 into 12. Okay. Why did I write like this 11 into 12? So that 12 can be taken common factor here. So that is n minus 1 into 12 is equal to, here I can take 12 and 12 common factor here. It is existing in both the terms. It is 53 plus 11. So what happens here? This 12 and 12 can be cancelled. So what you are left with now? N minus 1 is equal to 53 plus 11 is 64. So n is equal to what? 64 plus 1. N is equal to 65. Then what is the meaning of this n equals 65 here? That means T65, 65th term will be 132 more than its 54th term. Okay. If you find 65th term and keep equation 1 and find 54th term, add 132 to that, both LHS and RHS will be equal. So 65th term of the given AP will be 132 more than the 54th term. Okay. So we have solved quite a few good problems based on nth term of AP. In the coming video, I will take some more problems, that too some problems which were given in the board examination. We will discuss in the next video. Okay, I hope all of you understood all the concepts what we have discussed in this video, and keep watching the coming videos also. Okay, that's all from this video. Have a good day.